What is regression analysis? Let's say you are planning a marketing budget for the upcoming year, so you try to figure out how much advertising affects your sales performance. Or maybe your manager is planning to send employees on training courses, so he or she tries to figure out how training impacts productivity. To find out those answers, beyond educated guessing, there is one famous methodology which can be used to forecast a variable's behavior. You probably already learned about it. That is regression analysis. Based on the definition in Wikipedia, in statistical modeling, regression analysis is a set of statistical processes for estimating the relationships among variables. The focus is on the relationship between a dependent variable and one or more independent variables. Oh wait, don't just go away yet. What it means is that regression analysis is primarily used to explain relationships between variables and help us build a predictive model. For example, the relationship between temperature and ice cream sales could be studied through regression. In this case, ice cream sales is the main factor you're trying to understand and predict, so we call it a dependent variable. On the other hand, independent variables are the factors that might influence the dependent variable. In this case, we only have one, which is temperature. As long as you have a dependent variable and independent variables, regression analysis can tell you a story about your dataset. Note that, don't get confused. There are many names for a regression's dependent variable. It can be called an outcome variable, criterion variable, endogenous variable, or regressand. Also, the independent variables can be called exogenous variables, predictor variables, or regressors. In the following video, we'll just call them dependent and independent variables, respectively. To determine their relationship, a regression model is an algorithm that tries to fit itself to your data best, which is a line of best fit. This best fitting line represents the general direction in which the data is going. It can be linear as a straight line through the data, or nonlinear like an exponential curve, which curves upwards. By fitting a line or curve to the data, you can then make predictions to explain the relationships between one dependent variable and one or more independent variables. There are three major uses for regression analysis, which are 1. Determining the strength of predictors. That is when you want to figure out if independent variables have significant relationships with a dependent variable. 2. Forecasting an effect. That's when you want to predict a dependent variable, such as expected sales for next year. And 3. Trend forecasting. Sometimes you just want to have a general idea of the trend from your dataset. The benefits of regression analysis can help market researchers, data analysts, or data scientists to eliminate and evaluate the best set of variables to be used for building predictive models. There are several different types of regressions. Linear regression is usually the first modeling algorithm that people pick while learning predictive modeling. As we mentioned earlier, linear regression establishes the relationship between dependent variable and one or more independent variables using a best fit straight line, also known as regression line. In this tutorial, we'll focus on a simple linear regression, sometimes called ordinary least squares or OLS regression. Popular business software such as Microsoft Excel can do all the regression calculations and outputs for you, but it's still important to learn the underlying mechanics. To run a regression analysis, first, we plot our data points. And the best way to display the data is through a scatter plot. The x-axis is the independent variable, and the y-axis is the dependent variable. Next, a best fit line in a linear regression is a straight line. It means that you're growing steadily and you are progressing at the same rate over time. Mathematically, a simple linear regression is defined by this equation: y equals bx plus a plus epsilon. The formula states that forecast of y is conditional on x and an error term. If you remember, we've covered these two variables, x as an independent variable and y as a dependent variable. Now, we focus on the remaining terms in this equation. A is the intercept, which is the expected mean value of y when all x variables are equal to 0. It's the point where the line crosses y-axis. B is the slope of a regression line, which tells us expected change in y over unit change in x. Epsilon is a random error term, which is the difference between our best fit line and the actual value. In other words, it's the distance between the actual value of a dependent variable and its predicted value. It's also known as residual. In Excel, they do the error term calculation behind the scenes. So you do linear regression using the least square method and seek coefficients a and b such that y is equal to bx plus a. Now, the question is, how do we obtain best fit line? There are different ways to find a and b. In Excel, we'll show the three methods to perform linear regression analysis, and in the following, we'll go through the instructions on using each method. We're using the example of ice cream sales from mathisfun.com. In this example, we're going to do a simple linear regression in Excel. What we have is a list of daily noon temperature for the last 12 days in column B, which is our independent variable, and how much ice cream the local shop sold in column C, which is the dependent variable. Of course, there are many other factors that can affect sales, but for now, we focus only on these two variables. If you just need to quickly visualize the relationship between two variables, a linear regression chart is a good start. Here is how. With your data, select the two columns. Don't forget to include headers. On the Insert tab, in the Charts group, click the Scatter Chart icon and select the Scatter thumbnail. That'll be the first one. Here, we just create a scatter plot. Now, how to draw a least square regression line. Click on the plus icon on the right top corner, which is Chart Elements, and check Trend Line. Then click the black triangular to choose more options. On the right pane, select the linear trend line shape. And optionally, check Display Equation on Chart to get your regression formula. Also, check Display R-square value on Chart, and the value will appear next to your line. Alright, we just make a scatter chart with a linear regression line. Let's talk about the results. The major outputs you need to be concerned about for a simple linear regression are the R-squared, the intercept, and the slope coefficients. R-squared is the coefficient of determination, which is used as an indicator of the goodness of fit. This R-squared number between 0 and 1 indicates how much your trend line actually fits the shape of your scatter plot. The R-squared value is calculated from the total sum of squares, meaning that it is a sum of square deviations of the original data from the mean. The closer to 1, the better the line fits the data set, indicating more accurate models, so you want to be fairly close to 1. In our example, the R-squared is about 0.91, which is a very good fit. It means that 91% of our values fit the regression analysis model. In other words, 91% of the dependent variables are explained by the independent variables. Next, we have the intercept of 694.37, which tells us if the change in temperature was forecasted to be 0. Okay, just saying, if that were the case in the area of this local shop, mathematically, our sales would be about negative 694 units. In reality, by strict definition, the sales can't be negative though. And finally, the slope of 16.71 tells us if temperature increases by 1%, sales will likely go up by about 16 units. Alright, that's for the scatter chart with a linear regression line. Let's move on to the next method. The second method is to run regression in Excel by using data analysis. Analysis toolpak is available starting from Excel 2003 version, but it's not enabled by default, so you need to turn it on manually. If you've already done that, you can skip this part. In your Excel, click File, then Options. In the Excel Options dialog box, select Add-ins on the left sidebar. Make sure Excel Add-ins is selected in the Manage box, and click Go. In the Add-in dialog box, check Analysis Toolpak and click OK. This will add the Data Analysis Tools to the Data tab of your Excel ribbon. Once we enable the Analysis Toolpak, let's start the steps to perform regression analysis. On the Data tab, in the Analysis group, click the Data Analysis button. Select Regression and click OK. In the Regression dialog box, select the input Y range, which is your dependent variable. In our case, is ice cream sales. Select the input X range, meaning the independent variable. In this example, is a daily noon temperature. Check a label box because we have headers at the top of the X and Y ranges. Choose a new worksheet in the preferred output option. Optionally, select the residuals checkbox to get the difference between the predicted and actual values. Click OK. Here shows the output. We break down 4 major parts from the outputs in the following. In summary output, the first one is multiple R. It is the correlation coefficient that measures the strength of a linear relationship between two variables. The correlation coefficient can be any value between -1 and 1, and its absolute value indicates the relationship strength. The larger the absolute value, the stronger the relationship. +1 means a perfect positive linear relationship. -1 means a perfect negative linear relationship. 0 means no linear relationship at all. From our results, multiple R is about 0.95. It shows a strong positive relationship between ice cream sales and noon temperature. The second one is R squared, which is the square of correlation coefficient, meaning that R squared is the square of multiple R. If you remember, it shows that 91% of our values fit the regression analysis model. As you may notice, the R squared value is also 0.91, which is the same as the first one in scatter chart that Excel has created for us. The third one is adjusted R squared. It is the R squared adjusted for the number of independent variables in the model. For the cases in multiple regression analysis, you will want to use this value instead of R squared. Standard error. It shows the precision of the regression analysis. The smaller the number, the more certain you can be about your regression equation. Observations. It is simply the number of observations in your model. So we have 12 data points in this example. The second part of the output is a ANOVA table, or called analysis of variance. The ANOVA table in the output will give you the p-value and F statistic. These statistics help you figure out how well a regression model fits the data. Basically, it splits the sum of squares into individual components that give information about the levels of variability within your regression model. dF is a number of the degrees of freedom associated with the sources of variance. SS is the sum of squares. The smaller the residual SS compared with the total SS, the better your model fits the data. MS is the mean square. F is the F statistic, or F test, for the null hypothesis. It is used to test the overall significance of the model. Significance F is the p-value of F. The value gives you an idea of how statistically significant your results are. If p-value is less than 0.05, your model is okay. If it's greater than 0.05, you would probably better choose or consider another independent variable. In our results, p-value is less than 5%, so our model is okay. The coefficient section provides specific information about the components of your analysis. It enables you to build a linear regression equation in Excel. For our dataset, where Y is the ice cream sales and X is the daily noon temperature, our linear regression formula goes as follows. Y is equal to noon temperature coefficient times X plus intercept equipped with the A and B values. It turns into Y is equal to 16.72 times X minus 694.37. For example, with noon temperature equal to 78 degrees, the ice cream sales would be approximately $16. In a similar manner, you can find out how much ice cream is going to be sold with any other noon temperature you specify. As you may notice, the linear regression formula we built based on the coefficient output is the same as the regression equation Excel has created for us. The last one is residuals. If you compare the estimated and actual number of sold ice cream corresponding to the daily noon temperature of 77 degrees, you will see that these numbers are slightly different. The estimated of 595.73 versus the actual of 614. Why is different? Because independent variables are never perfect predictors of the dependent variables, and the residuals can help you understand how far away the actual values are from the predicted values. For example, for the 8th data point, noon temperature of 77 degrees, the residual is approximately 18.26. So we add this number to the predicted value and get the actual value as 614. Alright, that's all for the linear regression with analysis toolpak. Let's move on to the last method. Microsoft Excel also have a few statistical functions that can help you do linear regression analysis, such as slope, intercept, and correlate. Let's make a formula for our sample data set. We can calculate A and B individually by using these functions. To get the y-intercept, type equal to intercept and select the data area. To get the slope, type equal to slope and select the data area. Additionally, you can find the correlation coefficient that indicates how strongly the two variables are related to each other, equal to correl. Okay, with the functions of slope, intercept, and correl, we can find the linear regression formula as well. In this tutorial, we've learned the basic background in linear regression, and we also demonstrated 3 methods to run linear regression in Excel. Bear in mind that regression uses historical data. This is only an indication of your past growth. Anything can happen in the future to throw off your sales. Naturally, there's a lot more to learn. That's it, folks. By now, you should have an idea of how to explain relationships between variables and build a predictive model with simple linear regression. From this example of an ice cream shop. Hope the video is helpful. Please leave your feedback or comment down below. Thanks for watching. If you like it, please subscribe for more tutorials. See you next time.